Hi everyone, this is the last video for section 5.2 on primes and composites. So I've mentioned kind of throughout the videos that the prime numbers are studied a lot in number theory and why they're kind of important for our everyday lives. But they also give us some really interesting numbers. If you ever do math competitions or are the coach for example, UIL and middle and high school, they do math competitions like this that sometimes deal with these types of numbers. So it may just be a nice thing that you've seen before in case you ever end up doing anything of that sort. So let's start talking about them. So we have divisors of, we have factors of things, and a factor can be called what's called a proper divisor if it's just less than the number. So a proper divisor is just a factor or a divisor that's less than the number. So for example, with the number 6, we know that the factors of 6, or equivalently, the divisors of 6 are 1, 2, 3, and 6. So if we wanted to list out the proper divisors of 6, that is just 1, 2, and 3. So 6 is not a proper divisor of itself. So this word proper comes up multiple times in different mathematical concepts. If you can remember back to chapter 2, we were dealing with proper subsets and just subsets, where the proper subset could not be equal to the set. Similarly, a proper divisor cannot be equal to the number. But this is just a little note here. And so the reason that we wanted to bring this up is because we want to talk about the notion of a perfect number. So a perfect number is a number such that the sum of the proper divisors is equal to that number. And the smallest example is 6. So we want to show that 6 is a perfect number, so that 6 is the sum of its proper divisors. So if we add up the proper divisors of 6, we get 6. So this one's a really easy one to check. I think the next smallest perfect number is 20, I think, or it's in the 20s. Let me check if it is 20. So the proper factors of 20 are 1, 2, 4, 5, and 10. So when we add these up, you get 22. What is the next perfect number? I know it's in the 20s. Let me look it up right quick. Is it 22, maybe? 28. So it's actually 28 is the next perfect number. So the proper factors of 28 are 1, 2, 4, 7, and 14 are the proper factors of 28. So 1 plus 2 is 3, plus 7 is 10, plus 14 is 24, plus 4 is 28. So this is 28. So yeah, the perfect numbers are kind of sparse. So the perfect numbers, we can list them, are 6, 28, 496, 8,128, and so on. So you can always find them. But yeah, like I said, they're really sparse. This, I believe, is named after people who did math way back in the day. So like the Greeks, they noticed this and really liked this property, and they thought that it made a number perfect. So that's why they're called perfect numbers. But yeah, the only time I've seen this actually applied anywhere is in math competitions, where there's lots of different numbers that have these kind of funny names. Okay, so the next type of numbers I want to talk about are abundant and deficient. So again, these also deal with proper factors. So a number is abundant, right? So perfect means the sum of the proper divisors equals that number. Abundant means the sum of the proper divisors is greater than that number. And likewise, a deficient number has the sum of the proper divisors less than that number. So let's kind of look at examples of these. So the easiest ones to look at, let's look at 4. Because the proper divisors of 4 are only 1 and 2, right? Normally we would have 1, 2, and 4, but we can't include 4. So then we notice that 1 plus 2 is 3, which is strictly less than 4. So 4 is deficient. And we can also look to find an abundant number at 12. So you can pick any number to look at. We could have even just picked 7 and 8, just around 6 to see what happened there. But kind of the motivation behind picking 4 and 12 was that we know that 4 is a square. 4 is a square with the only other factors being 1 and 4. So that was kind of the motivation there, because I knew we would only have the 1, 2. And 12 has a lot of different factors. So the proper divisors of 12 are 1, 2, 3, 4, and 6. So this has a lot. It's divisible by a lot of things. So when we add 1, 2, 3, 4, and 6, we get 16, which is bigger than 12. So that means that 12 is abundant. So yeah, we just have these 3 different notions for the 3 different cases for the sum of proper divisors. Is it less than, equal to, or greater than that number? And we have these different things for it. You can kind of notice, because these are the only 3 cases, that every number will either be perfect, abundant, or deficient. Like whenever we listed out those perfect numbers, you can see that those are really sparse, right? There's not a lot of them. But every other number that's not perfect will either be abundant or deficient. Okay, so the last things I wanted to talk about are amicable numbers. So amicable numbers are a little bit different concept. So now 2 numbers are amicable if they have this property that work well with each other. So this is a pair of numbers. So these 2 numbers are amicable if the sum of the proper divisors of one is equal to the other. So let's just kind of look at that. So let's look at the factors of 220. So we can just kind of talk through these divisibility tests really quick. That it's divisible by 1, 2, not 3. It is divisible by 4. It's divisible by 5. It's not divisible by 6 because it's not divisible by 3. Well, I guess we're not going to talk through it. I'm just going to tell you what the factors are, and you can double check it on your own. The factors of 220 are 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, and 110, and 220, lastly. So if we sum up the proper divisors of this number, if we look at 1 plus 2 plus 4 plus 5 plus 10 plus 11 plus 20 plus 22 plus 44 plus 55 plus 110, we will get exactly 284. Okay, so at first this may seem, yeah, big deal. That means that this is an abundant number, but why do we care? It's because if we look at the factors of 284 now, so the factors of 284 are 1, 2, 4, 71, 142, and 284. So this one has a lot less factors. If we add them up, 1 plus 2 plus 4 plus 7, D1, plus 142. If we add these up, we're going to get exactly 220. So that's why these are called amicable, because that means that one will be abundant, one will be deficient, but that the sum of their proper divisors will equal each other. So this is just another way to kind of relate special types of numbers and proper divisors. Okay, so that's all that I had to say about primes and composites over the things in section 5.2. And so that's all for this video.